Welcome students. In the previous class we have discussed about chemical bonding. So chemical bonding we have started our second chapter. Today we are going to explain the other thing related with the chemical bonding. So chemical bonding is a type of attractive force. Chemical bonding is a type of attractive force that hold the atoms in a molecule. Now we are going to discuss about there are mainly two types of chemical bonding. Two types of chemical bonding. First one it is ionic bond or ionic bonding, and second one it is covalent bonding. Ionic bonding and covalent bonding. So ionic bond and covalent bond. So there are two types of chemical bonding is there. One is ionic bond and covalent bond. Today we are discussing related with the ionic bond. Okay, ionic bond. So what is ionic bond and which are the compounds formed by this bond and what is the nature of this bond? Okay, now we are familiar with a compound. It is sodium chloride. So sodium atom combined with chlorine and it forms a compound that is known as sodium chloride. So NaCl, it is sodium chloride. Sodium chloride. So sodium chloride is formed by the combination of sodium and chlorine. Now we are going to discussing about the bonding between sodium and chlorine to form the compound sodium chloride. Look at here, sodium, its atomic number is 11. Sodium, its atomic number is 11. If you write the electronic configuration, we can write it as 281. Okay, and chlorine, its atomic number is 17. If you write the electronic configuration, we can write it as 287. Okay, now we are going to discuss about the formation of the bond by combining these two atoms, sodium and chlorine. So sodium and chlorine, we are discussing that in the case of sodium. Look at that, the electronic configuration again we are writing it is 281. The valence shell contain only one electron. The element is not stable. To attain the stability, there are two chances for this element. To attain the stability, this atom have the two chances. So what is the chances? One chance is to donate the one electron, donate the last electron. Another chance is accept 7 electrons. Donate the last electron or otherwise they have to accept 7 electron. An atom always do the thing that is need less energy. The atom will do always the thing that is need less energy. That implies to donate one electron and to accept one electron that require equal amount of energy. To donate one electron and to accept one electron, an atom need equal amount of energy. So here they have the chance to donate one electron or accept 7 electron. So to accept 7 electron that need more energy and less energy is required for donate one electron. So the thing that need less energy the atom will do always. So it is easy to donate one electron. So that's why the sodium in this reaction that will donate one electron to attain the stability. If the one electron is donated from the valence shell, the electronic configuration is changed to 2,8. Now look at the last shell, how many electrons are there? 8 electrons. So this element is stable now. That atom is stable now. Sodium that have 11 electrons. The 11 electrons are written as 281. One electron is donated to attain the stability and it is become as 2,8. If an atom that loses electron, that will get positive charge. If an atom that loses electron, it will get positive charge. If that donate one electron, that will get one positive charge, and accept one electron, if it is accepting, that will get a negative charge. So we are discussing the second one related with the chlorine. Now look at here, chlorine, its atomic number is 17. Electronic configuration is 287. The valence shell contain 7 electrons. That valence shell contain 7 electrons are there in the valence shell. So there are two chances to attain the stability. What are the chances to attain the stability? Yes, the first chance is to donate 7 electron and accept 1 electron. Which is easier? Whether donating 7 electrons or accepting 1 electron. Yes, it is easy to accept 1 electron because that need less amount of energy. If that accept 1 electron, the electronic configuration will be become as 2,8. 8. The electronic configuration become as 288. That time the valence shell have the 8 electrons. It is stable. So sodium donated 1 electron and chlorine accept the electron. Then an atom accept electron, that will get negative charge. That will get negative charge. Sodium chloride is formed by the combination of sodium and chlorine. That sodium get a positive charge and chlorine get a negative charge. The sodium ion and chloride ion. The ion, that means charged atom. An atom that get charged, it is generally known as ions. Okay, so ion, positive ion and negative ion. So we are representing the electronic configuration related with the bonding between sodium and chlorine. That means the compound is formed by the combination of sodium and chlorine. Okay, before the reaction, in the case of sodium, before the reaction, that means combined with the chlorine, that have 11 electrons, electronic configuration 281. When that is donated 1 electron, that electronic configuration is become as 28. After the bonding or after the reaction, it will become 28. In the case of chlorine, its electronic atomic number is 17, electronic configuration 287. Then that accept 1 electron and the electronic configuration is become as 288. After the reaction, 288. In the case of sodium, after the reaction, the electronic configuration is 28. In the case of chlorine, after the reaction, the electronic configuration is 288. So in these two cases, there is no change in the number of proton, but there is change in the number of electrons, because here 1 electron is lost and here 1 electron is accepted or gained. So there is no change in proton. That's why the sodium get a positive charge and chlorine get a negative charge. So the bonding between sodium and chlorine, it is an easier method to represent the bonding by using dots. So we are going to discuss about the electron dot diagram of the bonding between sodium and chlorine. In electron dot diagram, we want to represent the valence electrons. Only we want to need to represent the valence electrons by a dot. For example, sodium electronic configuration is 281. The valence shall have 1 electron. So we are representing the valence electron as a dot here. Then that is combining with the chlorine, is electronic configuration 287. How many electrons are there in the valence shell? 7. So we are representing the 7 electrons in the outermost shell on the atom. 7 electrons. So 2, 4, 6 plus 1, 7 electrons. So now we are going to discussing the bonding between sodium and chlorine. What the sodium will do? The sodium donate the electron to the chlorine atom. Sodium donated 1 electron. If an atom that donate 1 electron, what happens? So if an atom that donate 1 electron, that will get a positive charge. So we are represented in the square bracket, in the top portion we are representing a positive charge. Then the electron is lost now. There is no electron. This is lost and electronic configuration is become as 28. So we are representing 28. That valence shell is 8 electron. That is no need to represent here because it is lost the valence electron. So positive charge is represented. Next, chlorine that accept the electron. If it is accepting, there are 7 electrons in the valence shell. 1 more electron is accepted. Now it is become as 8. If it is become as 8, that will get a negative charge. The electronic configuration is 288. The electronic configuration is 288. Now these two atoms are attained stability by donating and accepting electron. So there is a positive charge in sodium and there is a negative charge in chlorine. If an atom that get a charge, that is known as ions. Okay, ions. So this is a positive ion and a negative ion. So there is an electrostatic force of attraction between the atoms. Electrostatic force of attraction between the atoms. Okay, then sodium combining with the chlorine. The positively charged ions are known as cations. Positively charged ions are known as cations and negatively charged ions are known as anions. Positively charged ions are known as cations and negatively charged ions are known as anions. So here, which is the cation? Na plus. Sodium ion is the cation. And which is the anion? Anion in this case, chloride ion. Chloride ion, Cl minus, that is known as chloride ion is the anion. So there is an attraction between the cation and the anion. So here electron transfer will be takes place. That means sodium donated and chlorine is accepted. So electron transfer. If a chemical bond that takes place by the transfer of electrons, such type of bonding are generally known as ionic bonding. Ionic bonding. So ionic bond formed by the transfer of electron between the atoms, and they are attracted together by the electrostatic force of attraction. By the means of electrostatic force of attraction, they are two ions are attracted together. Okay, these are the things we are discussed about the ionic bonding. Next, we are going to discuss the ionic bonding in the case of magnesium oxide. Magnesium oxide. Before that, in the case of magnesium oxide, we are going to familiar one more thing that is related with the equation we are writing related with the ionic bond. That means in the case of sodium chloride, sodium donated one electron and become as Na plus. So Na plus plus one electron. That means Na become as Na plus by the donation of one electron. If an atom that donate the electrons, we want to write at last. In an equation, if an atom that donating electron, you just write, if it is 1 or 2 or 3 electrons, you just write it at the last of the equation. So Na gives Na plus plus 1 electron. At the same time, what the chlorine will do? The chlorine accept the electron. So Cl plus 1 electron. Cl plus 1 electron gives Cl minus. Here the 1 electron is accepting. Accepting, that implies we are to write at the first section of the equation. So Na became as Na plus by the donation of 1 electron. Chlorine accepted 1 electron and that will get a negative charge. So Na plus and Cl minus attracted and forms a compound. It is NaCl, sodium chloride. Ready? Like that, we are going to discuss about the formation of magnesium oxide. Magnesium oxide. Magnesium, its atomic number is 12. So electronic configuration 2A2. Oxygen atomic number 8. Electronic configuration 2,6. So students, we are going to represent the electron dot diagram of magnesium and oxygen and the formation of magnesium oxide. Look at here. The electron dot diagram. Magnesium. Magnesium electronic configuration 2A2. We are representing the 2 electrons in the valence shell. Plus oxygen is atomic number 8 to 6. We are representing the valence electron. 6 electrons in the outermost shell. 6 electrons. Okay. 6 electrons. So to attain the stability, the magnesium will donate the 2 electrons. 2 electrons are there, it will be donated the 2 electron, and the oxygen atom that will accept the 2 electron. Now the electronic configuration will be formed. The 2 electrons are donated. Now the electronic configuration is 2, 8. So it is donated 2 electrons and it will get 2 positive charge, 2 plus. Okay, the same time in the case of oxygen, 6 electrons are there in the valence shell. The oxygen 6 electrons are there already in that atom, and that will accept the 2 electrons from magnesium, and now it is become as 8, and it is accepted 2 electron and it get 2 minus charge, and electronic configuration is also 2, 8. So magnesium donated 2 electrons and oxygen accepted the 2 electrons, 2 positive charge and 2 negative charges. So they are attracted together and form a compound. It is MgO, magnesium oxide. So that is neutral compound is formed. This is related with the ionic bond, and you do the activities given in your textbook related with the ionic bonding. Okay, thank you.